Hey guys, I hope you're doing great. Today I'm going to show you how to graph a quadratic function. So the graph of a quadratic function is named a parabola. And the most common one is this one, y is equal to x squared. This parabola right here looks just like this. It's basically a U-shaped function. And why is that? We can find it out by simply plugging some numbers. So if we take 1 for instance, 1 squared, that's going to be 1. 2 squared, that's going to be 4. And as we go on, it simply goes up, right? So for example, 3 squared, that's going to be 9. Cool. For the left side, for the negative part, it's going to be exactly the same, because any number that's negative but squared is always going to be positive. So minus 1 squared, that's going to be 1. Minus 2 squared, that's going to be 4. And we go on. Cool. So this is the most typical parabola. And the thing is that parabolas can also be slightly more difficult. They can, for example, look like this. And I'm going to show you how these transformations simply make the function go to the right, to the left, or up or down. Now, our second parabola is this. Y is equal to x minus 1, and the whole thing to the second power. Now, whenever we have this particular way of describing the function, we simply have to find where this, or what we have to plug in instead of x to get 0, right? And what number minus 1 is going to be 0 when x is equal to 1, right? And so that's why we start from this point, 1. So what this basically tells us is how much we have to go to the right or to the left. And we always have to go to the place where the function gives us 0. And now what we're doing, we're basically doing the same function as here, but we have to do it from 1 to the right. Okay? Cool. So it crosses the function where? In 1. How did I find this out? We simply plug in 0, and instead of x, and 0 minus 1 is going to be minus 1 to the second power, that's 1. And the rest of the function, careful here, we are 1 to the right. So the points, for example, if I plug in 2, the distance from 1 to 2 is still 1, okay? So it's like plugging in 1 to the second power, and that's still going to be 1. So we get this point and we go on. And again, we have to be careful. We have to always, 1 and 2, right? Not 3, but 1 and 2. So 2 to the second power, that's 4. We can write it down here. And for the left side, we found out that it crosses 1 when we go 1 to the left. And minus 1, if we go to minus 1, that's like minus 1, minus 2, right? And minus 2 to the second power, that's going to be 4 as well. So it crosses the line somewhere here, right? The third type of transformation can look like this. If we have, I'm going to use the same function, x minus 1 to the second power, but we can also have this, for example. We add 2. And so what this does to our function, we have this function. We can do exactly the same thing as we did before, right? We start in 1. But we have it, the function goes up by 2, okay? And so this is why we simply have, to start from 2 points above, okay? So what this tells us is basically where it starts on the y-axis. And given that here we do not have any number, it doesn't matter, right? But here we have plus 2, and that matters. So we have to start here. Cool. Now we once again just plug in some numbers, and find out what the function is going to look like. It's going to look like the same like here, but two points up on the y-axis. So we can see that it looks like this. And where is it going to cross our y-axis? Again, we plug in 0 instead of 1, and that's going to be 3, right? Here it's like, it's 2, right? But given that we start from 1, it's like the distance is only 1, so it's like 1 to the second power, so it crosses it here, so it's like going up by 1. Here, it is the same as plugging in 2, because yes, it is 3 on the normal axis, but we go by 1 to the right and by 2 to the right. So we have the function go by 2 up, and we also have to, do it to the second power, so that's going to be 4. And we have to add it, so it's 2 plus 4, that's 6. And the same goes to the left, so it's going to be somewhere here. And this is the third type of transformation we can have with quadratic functions. And now I'm going to show you the last type of transformation, and that is simply multiplying the function by a different number. So it can be like this, for instance, 2 times, and we're going to use the same function as before. And now we can apply the things we learned. So to find out where it's going to cross the x-axis, we have to find out when x minus 1, what do we have to plug in to get 0 here? 1, right? So we start here, 1. We go 2 up. Cool. And now we can start drawing our function. What this does, it's basically like, imagine starting the function from here and doing 2x squared. It's the same equivalent, And now we plug in some numbers. So if we plug in, like, it's 2 on the normal axis, but it's like the distance between the beginning of our function and the next point is 1, so it's like 1 to the second power, that's 1, but it's times 2, so it's not just going to be 1 up, but it's going to be 2 up, right? So we have to go by 2, but we are already in the height 2, so it's like 4. Great. The same goes for the left side. It's 2, but as we can see, it's going to cross it here. And we draw our graph.